All right, the first thing we're going to do is we're going to build applications that work well considering the production environment. Obviously, we're not talking about the application software here itself. What we care about is how that application lives in production. And there are two dimensions to that. Obviously, we have to first get to production. That means packaging your application in such a way that it can be used effectively in production. And then there is the ongoing life of the application once in production. And we support that ongoing life through observability. So we'll look at those two dimensions, but we'll do so by looking at a real application. We're going to build a service, which I'll just call service. We'll use Java 17. We're going to bring in the Spring Native support, the actuator support, the H2 in-memory database, R2DBC, and the reactive web support. We'll hit generate and open this up in our IDE. Now this is just a traditional, typical application. It's going to talk to a database, so we'll create a type customer, integer ID, string name, and we'll have an ID field, and we'll have a reactive repository to manage data access with that type, like so. And that's pretty boring, but that does give us most of what we want. Now, what I want to also do is to support writing some data into the database when the application is ready. So I'll create a listener here, and you'll see me do this or some variation of this a lot. I like to initialize things when the application starts up. And so here, all I'm going to do is I'm going to say, I'm going to put some people in the database, some friends of mine, right? So okay, and then E is a long one. There we go. And we'll say for each name, I want to turn it into a new customer, like so. And then for each one of those, I just want to save the record in the database using the aforementioned just created customer repository. Okay, so we'll say customer repository dot save C, good, and then we'll just subscribe to the results like so. Okay, good. There's our listener, and that's basically it. I guess we can create a REST endpoint, something very simple to show us the data. So we'll say at controller, at response body, class, customer, HTTP controller. And I'm going to inject this repository, and I could create the constructor myself, but I prefer to use Lombok for this kind of stuff to generate the constructors for me for all final fields. And that's easy enough. Like, just say at required args. We have to refresh this, of course. Good. Required args constructor. All right. And with that done, we just create an endpoint. Customers get this.repository .find all. Okay, there's our basic repository. Now, this is it. This is not important. This is not interesting. It's just a trivial, boring application. What I care about is observability first. So I will enable certain endpoints that allow me to better understand how the application is doing. And now I won't revisit all the details of the actuator. The actuator are a set of managed HTTP endpoints. You should use them. They give you visibility into the state of the application. In particular, though, what I care about are the Kubernetes probes. Okay, so I'm going to say I want to enable all the health details just for our demo here. And I want to enable the probes, which I can specify like so, enable probes, and then I'll restart the application. The application is complaining because we don't have a database schema. Okay, so easy enough. Schema.sql, create table customer, ID serial primary key, name varchar 255, not null. Okay, good. There we are. There's our application. It's up and running. We can see as much customers. Okay, everything is fine. What I care about, like I say, is the actuator. There's all these different endpoints, and we don't have time to look at all of them, but what we care about here is the health endpoint, which gives me information about the health of the application, right? So you click on health, and you can see it shows you all the different subsystems that might fail. Your disk space, your connection factor to the database, etc. You also have readiness and liveness. in Kubernetes, a liveness probe tells Kubernetes whether the service, the process, the web app, whatever, is still running. A readiness probe tells it whether it's ready to start running. And so you can access these endpoints through the actuator health liveness and actuator health readiness probe endpoint URIs. All right, that gives us the ability to ask, is the service okay? If something goes wrong and the service becomes sick, the container orchestrator will kill our pod. It'll destroy the pod and then deploy a new instance. We want to make sure that if we are doing anything while the application is running and while the service is being shut down, that we have some time to let that work finish. Okay, so we will use graceful shutdown. Okay, and of course we want to make sure that we have enough time, so you can configure how much time to wait between the sig term and sig kill signal is sent to the pod. You have to make sure that this value lines up with the configuration for the grace period in your Kubernetes pod or service or deployment configuration. Now I want to be able to test all this out. And so one thing that's very interesting here is that we can actually influence the probe by using events. Some of you may know that Spring actually has an event bus where components are able to talk to each other, one component to another in the same application context. So let's create availability HTTP controller, and this will use private final application context, and we're going to create an endpoint here called down. When you call this endpoint, we'll publish an event in the context telling the rest of the application, including the liveness probe, that something is broken. I also want to have an endpoint called slow, and when you call this, it'll create some work that takes a long time, right? It'll just arbitrary block. And so I'll say down, throws exception, slow, okay, thread.sleep 10, so 10 milliseconds, 10 seconds, 10,000 milliseconds. Okay, let's now restart this. Okay, we can go here. We can see the liveness is up, and if I go to the command line, curl -v, I can see it says 200. Now that we have the application up and running, I'm going to call the slow endpoint, and then I'm going to try and kill it, as we imagine the Kubernetes system would do. And you can see it says commencing graceful shutdown, waiting for the active request to complete. A few seconds later, the request completes and the application process stops normally. Now, of course, we've published an event to trigger a change in the state, but it's also worth noting that you can listen for that change as well. So, availability change event, return. And here, I'm just going to log out the result. I'll say system out, event. Okay. Let's restart that. Okay, you can see it says correct, accepting traffic. Now if we call down, you can see it says broken, right? So it's good to be able to listen for those events to understand when the application is changing its health. Okay, we've got an application that's observable and manageable in production. Let's talk about getting it packaged for production. The first thing we want to do is to take advantage of GraalVM native image compilation. GraalVM is a just-in-time compiler, but it also provides a component called the native image compiler that proactively compiles your application into operating system and architecture specific binary code. We're going to use that to turn our application into a very lightweight application that takes very little RAM at production time. So we'll say Maven skip tests using the native profile clean package. Now this will take about a minute. Remember, behind the scenes, the GraphQL native image compiler is doing an analysis on all the code in the application. It's looking at all the types that we use in our code, and all the types that they use, and all the types that those types use, and it's determining which types are to be kept and which should be thrown away from the class path and from the Java runtime. There is a bit of a problem here in that this static compile time analysis can't see all the dynamic things that you might do at runtime, using reflection, JNI proxies, serialization, loading resources from jars, etc. So it's important that there be something to contribute configuration to tell the GraphQL native image compiler not to throw things away. That thing is called Spring Native. Spring Native is a project that we created to support GraphQL native image compilation for Spring Framework 5 based applications and workloads. That said, the real goal is to get to Spring Framework 6, which is due later this year in 2022. Spring Framework 6 has built-in support for GraphQL native image compilation. You don't need a separate project like you do for Spring Framework 5 and Spring Boot 2. All right, there's our application. We'll go to the target directory, and you can see that the compiled application is not very big. That is very quick to start as well. So, if I Control-C it, start again, it's very, very fast. 57 thousandths of a second, right? Very, very quick. And it's ready for packaging for production. Now, of course, I could build my own Docker file, but I much prefer to just let the tools do the job for me. One great way to do that is to use build packs. Build packs are a great way to take an existing application, like a Java application, and to turn it into a container. And in this case, I'm on a Macintosh M1, so I can't use the default build pack yet, but you can if you're using Linux or if you're in Mac Intel. But for now, I'm going to use a separate standalone builder that my colleague built to show you what happens. Maven, skip the tests, clean, Spring Boot, build image. We'll let this run. It'll take about 3 minutes, and it'll create a Linux, it'll take the code, compile it inside the Linux Docker container, and then give us a Docker image that has a Linux binary in it that we can then Docker tag and Docker publish and then use in our Kubernetes cluster. It is based on the amazing build packs technology. Control-C, Docker run, and there's the application running inside of a Linux container on Mac, right? I'm running on Docker desktop on a Mac, running Linux over emulation on my M1, and it's still only 67 thousandths of a second. All right, so clearly there is a lot of potential here for getting an application to production. All right, we've got an application. Of course, our clients are going to want to connect to it. This isn't Kubernetes specific per se, but I do think it's a good testimony to some of the incredible capabilities that arise when you have a really, really powerful container orchestrator like Kubernetes that makes deploying applications a snap. Once you feel ease and comfort in deploying new applications, then you have no fear in deploying lots of them. And this is very useful because you will have lots of different clients and they will need to talk to those services. And so in this section, we're going to look at some integration technologies. We're going to build a new service here called Edge. We'll use the Spring Cloud Gateway, the reactive web support, the Spring for GraphQL support, and I think that is probably enough for now. Now, an edge service is the first port of call for requests coming in from the outside world. It's a logical place to adapt incoming requests to transform them to work with the downstream services. So if you have Android and iPhone and all these different clients, you can normalize those requests at the edge before forwarding them on to the downstream service. The first thing we're going to use is Spring Cloud Gateway. Spring Cloud Gateway is a great way to proxy or forward or work with the different kinds of payloads while operating on the envelope of the payload, not usually the payload of the request, right? So you want to operate on the envelope of the request, not the payload of the request. You can operate on the payload of the request, but when you're trying to do something that's aware of the payload, that starts to become a more semantic thing. So we're going to use a Spring Cloud Gateway route. And remember, our edge service will live on port 9999. And we're going to say that when requests come into /proxy, we're going to forward them on to 8080. Okay, now I want to send them to 8080 /customers. So I'll use filters here to add the path. The filters are one of the most powerful parts of Spring Cloud Gateway. I can add response headers, I can do retries, I can do retries 10, I can do timeouts, I can do all sorts of things here. I can do rate limiting. I love that, right? I can do all sorts of different things here. So let's just see what that looks like. Okay. Localhost 9999 / proxy. Oh, did I forget to run the old service? Let's run this. And then I'll run this one. Okay. So now, there we go. There's the proxy data, no problem at all. Because I'm using M1, I get these goofy errors. You can fix that very easily by bringing in netty all and then reloading your build and restarting. Okay, so we have a proxy. This is good, but a lot of times, rather than having to add new views of the data, it might be very useful to have a view that the client can consume and where the client can get schema, introspection, they can get the ability to ask for more or less of the data that they want. And to support all these use cases, I think GraphQL is quite nice. So let's create a GraphQL service. Okay, we'll call this GraphQL. Create a new file here called schema.graphql. Type query. And we're going to have an endpoint here that gives us all the customer data. Well, of course, we need to actually enable the customer data. So we'll describe that type here. And we're creating schema here to describe an endpoint that will live off of a well-known field called a well-known type called query. So let's create that GraphQL controller. Okay, and I think we also want Lombok. I don't think I brought it in my first generation. Okay, required args constructor. And we're going to use the reactive non-blocking HTTP web client. Okay, builder.build. And we're going to create a handler to resolve the query that we are providing, right? So return all the customers. Now the customers, we need to create a DTO, okay? Data transfer object. So we'll say customer return this dot http.get.uri http localhost 8080 / customers, retrieve the data, body to flux, customer.class. Okay, so I'm just making a network call using my GraphQL endpoint, and it's a resolver for a field in the well-known type called query. I want to be able to interact with this data, so I'll enable the graphical console. I need to name this GraphQLS. And then restart. And there's our graphical endpoint. And there's our graphical endpoint. So now I can issue a query. And I want to get all the IDs and the names. And there we go. Now, of course, the nice thing about GraphQL is I can easily add to it by changing the schema. And the representation of the data in the schema can be separate or different from the way that the data is stored in the backend services. So, for example, I can add a new profile type that is a part of the customer. But of course, that could come from a separate microservice. So for example, schema mapping type name is equal to customer, but I'm going to return a profile, a new type. Now, I don't have another microservice called profile service, but you can imagine I did, and then you would see that this is how you would resolve it. You'd inject a reference to the root aggregate type. You'd say customer.id, and then restart. Okay, so I want to now get all the profile data, hit enter. But if I hit control space, and you can see there's a profile field. If I don't ask for it, great, no problem, I don't get it. But if I want it, I can ask for it as well, and I get that data back. So I don't pay the price of getting this data if I don't specify that I want the data. So now, if I want just the overview, I can have that. If I want the details, I can have that. GraphQL lets me have as much or as little of my data as I want, and I don't have to build a new endpoint each time. Hopefully this has illuminated some possibilities for integration. Configuration is critical if you want to have an application in production. Kubernetes provides two ways of communicating configuration to your application. One is an object called a config map, which is a dictionary of keys and values, and another is a secret, which is a dictionary of potentially hashed keys and values. Values, right? Both work and act the same for the purposes of what we're trying to do here today, and that is to look at how the different ways that Spring Boot can read and work with config maps in a Spring Boot and a Spring Cloud context when running on Kubernetes. So let's go ahead and build a new application here. I'm going to call it configuration. We're going to use the Cloud Bootstrap dependency, the reactive web support, Lombok, and the Spring Boot actuator. And we'll hit generate to generate a new project that we can open up in our IDE. So let's look at this application. I'm just going to start up the application, and I want this application, when it starts up, to listen for an event called application ready event and public void begin. And we're just going to print out a message, a key from the environment, right? So we're going to inject that environment here in the constructor, and I'll just say the message is this.environment.getProperty message. Okay, very good. So there's my application, but there is no message at the moment, right? I need to actually define a message. So I could, of course, just say message equals hello application.properties. Let's try that. And that works just fine. But what if I wanted to get configuration from a config map that's been connected to my application? Well, the first most common ways to connect config map configuration to an application are to either turn it into as an environment, in which case the keys in the config map just become environment variable names, and the values, of course, become the values of those environment variables. Those just work by default. So, for example, if I go to my program and go to environment variables, message equals hi env or EVs, environment variables. Okay, hit apply, hit OK. I'm just going to restart. Okay, so that worked, right? Of course, you can do something similar with in program arguments. You can say dash dash. In the program arguments section of your launch, you would say hello PVs, PAs. There you go, right? You could do that as well, and that would go up here in the program arguments. They've made this menu so hard. There, it would go like that, right? Now, as environment variables, this just works for free. It's worked since Spring Boot 1.0. You don't have to do anything special. Another alternative way to get that configuration is to get configuration in a config map turned into a volume, a directory, in which the contents are files, and whose files have as their names the config map keys, and whose values are whose contents are the values of those config map entries. And so you can do that. You can say I want to import config spring config import, and you point it to a config tree structure. So I'm going to pretend I'm running on Kubernetes here, and that I've got a config tree mounted on my desktop, right? So I'll make a directory here, config, cd config. I'll say echo message. I'll say message. It'll be hello config tree to message, right? So there's the file. Here's the directory, the contents of the directory. I'm going to connect my application thusly. So that message will come from there instead of program arguments or environment variables or the application.properties file. Okay. Now I'm getting configuration as I would in Kubernetes in a config tree. I can, in Spring Boot, cordon off that Kubernetes specific configuration and say that I want this to activate only when I'm in a in a Kubernetes context. So activate on cloud platform Kubernetes, and so everything after this line, and after the --# will be only activated when I'm inside of Kubernetes. I can also do this for objects. For example, here I can create a bean, and I can say conditional on cloud platform. Cloud platform is Kubernetes. So application listener ready event turn args system out. The application is running, right? Something like that, right? I can create a bean that is only active when we're in a Kubernetes context. Now you are running locally. Obviously, we're running locally on our machines here. What we want to do is make our application behave as though it was running in production. And I can do that by specifying the main cloud platform. You can do this as an environment variable, a program argument, of course. I wouldn't leave it here in application.properties for your production code, obviously, but because it'll automatically detect whether it's in Kubernetes or not, and you may not want it to act like it's in Kubernetes when you're not in Kubernetes. But for our demo, I'm just going to leave that there. It'll just keep things simpler because everything I'm showing you henceforth depends upon us, writing code in such a way that it thinks it's in Kubernetes. Okay, so we've got this event. We've got this specific thing that'll get run when we're in a Kubernetes context. Let's restart. Okay, so this application is running on K8s. Thank you very much. We know that now. If we get this, and we, by the way, notice that it didn't pay attention to that, which is nice. Hit apply, go back here, and we can comment this out, restart. And there we go. We have no message, right? Because it's not getting the config tree. There's no built-in default value. So we're just getting null there. Now, I also want to get sometimes configuration in a lively fashion, right? More dynamically, right? What I've shown you, the config map and the environment variables, works the first time you start the application. But what if you change the config map whilst the application is running? In this case, I will want something a little bit more intelligent. Spring Cloud has a module called Spring Cloud Kubernetes, and that module in turn contains support for both config maps, getting config from config maps directly, and for using Kubernetes as a service registry. So Spring Cloud Starter Kubernetes client config. I'm just going to bring that into the class path, and for it to do its work, it's going to need configuration to tell it where to find the Kubernetes cluster and what to look for once it gets there. That needs to be resolved, obviously, before we actually get the rest of the configuration for the application. That is, we need to first connect to Kubernetes, and then once we've done that, we get configuration from Kubernetes that might then inform things like which port we're running on and so on. So there's a life cycle here. We need to do one thing before the other. So to bootstrap that configuration resolution, we typically use a file called bootstrap.properties. And here we put things that we can use to identify the source of that configuration. The first is that the application has a name called Edge. We wanted to tell it that we are going to monitor config maps. That's optional. It's true by default. But there's a similar property for monitoring secrets, and that's false by default. So if you want that, make sure to enable this, okay? We are going to enable the reload of configuration. It's off by default. Okay. And we want to tell it to use a particular mode, right? I think it's, I'm not sure what the default is, but it doesn't hurt to specify event. And then we need to specify the namespace, right? And the namespace is for both the config module as well as just a generic API client that we've got that's fed into and that bootstraps the config client. So Kubernetes there's two different connections here, one to Kubernetes and one to Kubernetes for the config module in particular. And so we need to specify the namespace. Okay. So I'll say default and client namespace is true, or just say default. Okay, and that should be everything we need. Let's now try it out. Okay, so we're expecting to get configuration from our Kubernetes cluster. We're going to apply this config map. Okay, good. Okay, get config maps edge -o JSON, and you can see it's got application.properties equals, and it's got a single string, which is a property file, as we could use in Spring, where the message has a value of nin_how. So we want to connect and see nin_how printed out in the application. So let's restart the application. Okay, it has failed here because it doesn't think we're running in Kubernetes. I forgot to restore that. And actually, we probably want to make that clear even earlier since we're doing this now. Okay, so nin_how is the value, but now I want to get the value after I've changed it. I don't want to have to reload everything. So Spring Boot has a mechanism for that called the refresh event. And so here I want to say I want to get notified of both when the application starts and when configuration has been refreshed. Okay, so and you can actually use an annotation, a scope, Spring Bean scope called refresh scope on beans, and they'll get recreated with new configuration when this event happens. But you can also just listen for the event directly. So I'm going to go ahead and restart, and now we've got the ability to talk to the config map. We also want to be able to see if the value has changed and see if that works. So let's go back to our desktop config map, and just make this a little bit more interesting, I'll add some extra exclamation marks. I'm going to save the file. So just to confirm everything has worked, right? So I'm going to now apply that. But before I do, let's make visible the console of my Kubernetes app. So desktop config map.yaml, applying. And as soon as I did that, the new value was immediately visible. And it only restarted it triggered that event. It took 8 milliseconds to do that work. Okay. All right. So we've looked at a number of different ways to get configuration into your Spring Boot app in a dynamic way, right? When running in Kubernetes. Kubernetes is an amazing place to run your Spring Boot applications, but I also think Spring Boot is a great way to run your Kubernetes cluster. And what I mean by that is we have a unique opportunity with the arrival of native images in the Spring Boot ecosystem to build controllers, operators, things that actually manipulate the cluster for you. There are meta applications that control the cluster that help do provisioning and deployment and things like that. And there's no shortage of examples of clusters or custom controllers that were written to support some of the use cases for which Kubernetes just isn't well suited out of the box. And it's a testament to Kubernetes' strengths that it is composable and flexible enough to support all these amazing extensions through its primitive atoms, the building blocks of a given cluster, like a pod and a deployment, and through its very, very impressive, very extendable API. That API is just that, though. It's just an API server. It's just an API that manages it stores data, basically. You give it a YAML object and it writes it to a disk somewhere, or writes it to a cache, and then you can look up that object via query. You can actually say, given this key, give me the object. It's kind of like a database. And when people think of that, they're like, well, that's ridiculous, but it really is true. It's a database that stores data, and then programs, very much in the same way that JDBC clients connect to data sources like Postgres or MySQL or Oracle database or whatever. They connect to the API server and they look at the state of things and they do things in response to it, right? And this may seem magical or mysterious, but it's really just a client-server architecture. A program sitting on your laptop can talk to Kubernetes and ask it questions, and it can create new things all programmatically, right? So you can actually create new deployments, new pods, new services, new anything, right? You can also, through this API server, you can also define your custom objects, your own objects, and these are called custom resource definitions. But again, that's just another object of your own specification that doesn't mean anything unless a program acts on it, right? So if you create an instance of an object in Java, but nothing does anything with that variable, is that really interesting? Same thing for custom resource definitions. You can create millions of instances of that, but if no software is actually looking at that state and responding to it, then nothing interesting happens. And so when you see a controller, when you see somebody who in that fractal of a landscape page on the CNCF landscape page, has written their own custom controller, what they're doing is they're just programmatically creating things for you in a way that makes sense for the infrastructure that they're trying to land and make work on Kubernetes. So if you understand that, then it's pretty easy to move forward. What we're going to do is we're going to build a simple program. I wouldn't even call it really a controller, but just for now, we're going to use Spring Native and Lombok. And that's, I think, everything we need. Let me bring in the Cloud Bootstrap here just in case. And we're going to hit generate. I'll open this up in my IDE. And in Kubernetes, there's an API. And so obviously there are clients that you can use to talk to that. And for us to talk to it, we need to have a client on the class path. And there are two well-known implementations. One is the client Java's, the official Kubernetes Java client, for which, by the way, there is a Spring Boot integration. So, naturally, I'm going to use that one. But I also want to be able to turn applications written using this API into native images. So to support that use case, I'm going to use a library that I wrote called hints, okay? And all it does is it provides Spring native hints for various libraries. You can use, it doesn't matter how you write these Kubernetes clients, you can use the official Java client and its Spring Boot integration. You can use the Fabricate client from Red Hat. Either way, there are supported hints here so that you can turn those applications, so written, into Graalvm native images. So, okay, I've got now all the dependencies I care about on the class path. I think I've got everything I need. So here's our Spring Boot application. And basically, I'm going to create a application listener, application ready event runner, return new application listener, and we're going to use a generic Kubernetes API, and we're going to modify instances of v1 pod, which is the Java client representation of the object in the v1 core API called a pod, right? So we're going to inject a reference to a generic Kubernetes API that manages instances of pod whose plural form is v1 pod list. And we have to define this bean, right? Somebody has to define that. But before we do that, let's just write the code here, okay? So response will be apis.get, and we're going to pass in the namespace of the thing that we want to look up. So default, and then the instance will be just, I have an Nginx instance running on the computer. So if I say k get pods, you can see I've got Nginx, right? K get pods, there it is. Okay, so I want to get that. And I say, okay, well, assert is state, I guess, and then I can say response.isSuccess. The call to query a pod was not successful. Okay, and then I'll get the actual pod itself. So I'll say response.getObject, and that's a v1 pod, and I'll just log out the results. And to log that out, I'll just use lumbuck here. Okay, info pod, okay, toString. Now that's the basic framing of my client. Not a big deal, nothing fancy. I'm not doing a full-blown controller here, but you can see how easy it is to do what you're trying to do, right? You just create a generic Kubernetes API implementation for a given type and then use it. Now, I'm simplifying things considerably here, right? Actually, there's a lot more nuance that you really do need to sort of dive into, but suffice it to say, the Kubernetes API in turn delegates to something called a API client. And that's the level of that's the thing that the generic Kubernetes API uses, but it in turn gets used by a whole interesting thing called a shared index informer, and so there's basically three more specialized types. There's an informer, which is like a cache of data from the API, so that the client doesn't have to constantly make calls to the API proper, because there's a lot of back and forth with a given operator. And then there's a specialization of an informer that can be shared across multiple controllers and multiple concurrent accesses. That's called a shared informer. And if you want to query that shared informer and get objects from it via type, via key, that's called a shared index informer. And so those things are usually, you don't talk to the API directly. If you can avoid it, you talk to a shared informer, right? Shared index informer. But for our little example here, we'll just do this, right? So v1 pods, and of course we're going to use the API client, which the Spring Boot auto configuration will give us for free. Okay. Okay, good. So there's our basic client. Let's go ahead and run this, see what we get. All right, look at that. We ran the application. It started up and it gave us the objects, right? It gave us the v1 pod, the v1 status, and there's other methods here to create, to delete, etc. You get the basic idea. I'm not going to spend much more time on this. The only thing I want to do is to turn this into a native image using Spring Native. Okay, so maven -p native d skip tests clean package. All right, it's compiled. Let's go to the target directory here. And controllers. There we are. Run it again. You can see it's lightning fast. Takes up almost no RAM. You can deploy this to a cluster. Let me see, it started up in 33 thousandths of a second. So pretty great, right? And it'll take up 50, 100 megs of RAM, whatever. That's infrastructure you can deploy confidently alongside other things in the cluster and know that it's not weighing the cluster down. And it can do anything that Spring can do, right? It's a good fit.